Here, I'm focused on helping you understand how the pre-processing for keyword spotting is actually done. Now, if you remember, the pre-processing is something that happens in the main loop, and then something that gets repeated over and over. And it's got two major components, the audio provider and the feature extractor. The job of the audio provider, which is the first thing that we will talk about, is to continuously get audio signals from the microphone on the Arduino and to convert that into a digital representation that can then be converted into a spectrogram that is consumed by the neural network. Great. So let's see how we can actually go about doing this. So in order to get started with pre-processing, the first thing we have to do in our code, which is in the micro speech file, is to go down to the loop part. Remember, we are talking about everything that is inside of the main loop now. The first part of the main loop immediately jumps at populate feature data. The job of populate feature data is in fact to get the audio samples in a spectrogram format. Quite simple. Now, one of the interesting things here is that it takes the previous time and the current time. Previous time is the last time you called populate feature data. And the current time is the actual time that records, as of right now. In other words, what is the exact time just before you're calling this function? The question is, why are we passing these two things? The reason is because what populate feature data is going to do is going to try and figure out just how much time has elapsed since the last time the function call has been called, so that we know how much of the spectrogram data actually needs to get generated. So let's go ahead and look at what's inside populate feature data, which is inside the feature provider.cpp file. The first thing we do here is to do a quick error check. And the next major thing that we're going to be trying to do is to determine how many slices of data we need. Recall that a slice is a portion of the spectrogram. We have 40 columns by 49 rows of such columns. So a slice is one column inside of the spectrogram. So as we scroll down here, what this portion of code is trying to determine effectively is how many total slices of data we need to get. When was the last time we got some audio samples, and what is the current time? Now, this time might change between two subsequent runs due to some sort of runtime variability. So therefore, we dynamically try and compute how much time has actually elapsed. And what we want to do next is that we want to take our spectrogram array and we want to make room in the spectrogram for new data to come in. And that's what this portion of code is really getting at. And it's trying to age out the old data. So if the last timestamp was 80 milliseconds and the current timestamp is now 120 milliseconds, that means that we need to bring in 40 milliseconds of new data. And therefore, you see in the spectrogram data now, the audio buffer of the last sample was at 80 milliseconds. And this one is effectively, will be at 120 milliseconds. So that's the amount of data that we need to bring, which is in two major chunks, illustratively speaking. So this piece of code is effectively trying to determine exactly how much data that needs to be, and it's aging out the old data. And that's the most important thing. So think of it as making room for the new data to come in. Once we have made the room, the next section of code is primarily focused on actually bringing in that spectrogram data. Now, this has two major parts. The first part is actually getting the raw audio data that you will need for about 40 milliseconds worth of time. And the next step is once you have the raw audio data, then you need to generate or extract features that we need in the form of the spectrogram. And that's what generate micro features is doing here. So let's take a look at what's get audio samples is actually doing. And I'm going to go to the version that's in the Arduino audio provider. So if you scroll down a bit, this function has got a few key pieces. And if this is the first time that get audio samples function is getting called, it calls initialize audio recording. The job of initializing the audio recording is fairly simple. If the job is simply to set up the microphone, which I talked about previously to you in the presentation videos. And as you can see here, we are asking it to sample at 16 kilohertz. This is defined in the header file and with a gain of 20, which is pretty standard. And whenever there's new data that comes in, it puts it inside the capture samples buffer, which is defined earlier in the file. So going back to get audio samples where we had called in an audio recording, assuming that this is not the first time you're coming through. So therefore, we don't need to call this function anymore because the microphone is already set up. This portion of the code is effectively going on and trying to get audio samples from the audio microphone and then into the array that we have. And that's all that get audio samples is doing. It's actually getting us the raw audio. Now, if we go back to the feature provider.cpp file, the next thing to do is actually to look at what the features that we need. So therefore, after we have gotten the audio samples and done some error checking, we're getting into the part where we actually want to look at generate micro features. Now, generate micro features takes in the error handling in order to report errors, takes in the raw samples that came in, and it talks about about what the size of the samples need to be, and so it knows how much data to actually process and how much of the individual feature slice is and where to store that data and so forth. So if I'm going to get generate micro features and I look at that, that's defined inside micro features generator. And this is a portion of code that you typically don't need to touch. It's fairly advanced and it's kind of meant more for library writers, not application writers. You would usually not have come this far if you're developing just a high-level keyword spotting application. But that said, I would very much like you to have a feel of what the code is doing. And I'm not going to be stepping into the individual bits and pieces of this code, but generally the goal of this particular function is to do the FFTs and then is to actually generate the MFCCs and to get the spectrogram out for you. And that's what the front-end process samples is effectively focused on doing. Now, going back to our feature provider, you will see that once we're done with this, we simply return back. And that brings us back to where we were in the populate feature data, which is part of the main loop. And that's all that there is to generating the actual waveform data that is needed in the form of a spectrogram. So taking a step back again, you will look at the sequence that's involved. And what we're doing is going from collecting raw audio samples, generating the necessary frequency domain response of these signals, and then doing some MFCC or enhanced signal processing, and then generating a spectrogram out of that. And that spectrogram is what we will later use in the inference stage. So hopefully at this point, you understand what code is actually doing in the pre-processing.